Hi everyone, welcome to this lesson on Euler's method, a powerful numerical technique used to approximate solutions of differential equations. Euler's method is a numerical technique to approximate solutions to especially first order differential equations when a particular solution is given or the initial condition is given. Let us say we are given a differential equation of the type dy by dx is equal to fxy, and the initial condition is given, the initial solution or particular solution, which we say initial condition, initial point for a particular solution, and delta x be the step size. Now let us say this curve is of any shape like I have drawn on my right side, and we mark the points along the x-axis with x coordinate, initial coordinate x0. By using the initial condition, that is x0, y0, and the given first order differential equation, we can find the next point, y coordinate. So we can find the gradient, and by using gradient and the step size, we can find the next point, y1, the initial y coordinate plus step size times the gradient at the first point, gradient of the first point. Now we have x1, y1. By using x1, y1, we can draw the tangent. Let's say the shape of the tangent is somewhat like this. Now we have x1, y1, that's our new initial point. That is our new initial point. By using this point, we can find the next y coordinate, previous y coordinate plus step size times the value of the curve or the gradient at the previous point, that is x1, y1. Now we have x2, y2. By using x2, y2, we can draw the tangent. It's somewhat like this. Similarly, we have x2, y2 as the new initial or the solution, new initial point. By using this point, we can find the gradient, and by using gradient and step size, we can find the next y coordinate. The previous y coordinate plus step size times the gradient at the previous point, that is x2, y2, and so on, and so on, until we reach to the desired point, desired x value for which we want to approximate the y value of the solution to the given curve. Now we should keep in mind, the smaller the step size. Now here, what is the step size? This difference, two x consecutive x coordinates, that is delta x. That is delta x, the step size. So we should note that smaller the step size, greater will be the accuracy. What is this formula all about? Let's see the mathematics underneath. Let's say we have any curve, the first order differential curve, and we are in terms of n. So we will write it like this, the formula in terms of n, general formula, general Euler formula. So let's consider the initial point in terms of n is xn, yn. Let's assume the next point is with y and x coordinates as xn plus 1, yn plus 1, and the step size is same, delta x. Delta x is the step size. We can see the point A, point B. Now xn plus 1 means the next x coordinate is nothing but delta x plus the previous x coordinate, or we can say the next delta x is nothing but the difference of two x coordinates. And then for y, the gradient at point A is given by the curve, because we are given the curve. What is curve? First order ordinary differential equation, we can say, is given by this, and then we know the gradient or the line joining two points is the difference of y coordinates, that is yn plus 1 minus yn divided by xn plus 1 minus xn, and the value of the gradient or the tangent at A and the value of the differential equation or differential curve is same. So that means the point A will lie on that curve. So that implies divided by, what is that? That is delta x, that is equal to, so we can rearrange the terms. So previous y coordinate times a gradient at the previous point. Now what is yn plus 1? Yn plus 1 is the next y coordinate, current, or we can say the previous, and that is nothing but the gradient at previous point. Iterations means if you apply this formula repeatedly to reach to a desired point. How it's connected with fundamental theorem of calculus or integration. Suppose our desired point is desired x value is a, means x is equal to a, and the initial value is x0, initial value, and we let the number of steps be infinite. If number of steps approach to infinity, obviously the step size will approach to 0. So here, when the fundamental theorem of calculus comes into existence, then the value of the curve at the desired point A can be given by the value of the curve at the initial point plus area under the curve from the initial point to the desired point. What is the curve? Dy by dx with respect to x. That's nothing but fundamental theorem of calculus, or we can write it like this: fundamental theorem of calculus. Okay, let's understand Euler's method by using one simple example. For example, solve if given first order differential equation x plus y, initial condition is 0, 1, and step size delta x, in some books we use step size as h, or delta x is 0.1, and we have to approximate value of y at 0.3. So what we have to approximate? Approximate y at 0.3 using Euler's method. Okay, so we should remember the formula, general formula, which we have written in the previous discussion. Next y coordinate is previous y coordinate plus step size times the gradient at the previous point. We can form a table of values. So let's say x coordinate, previous y coordinate, gradient, and then we have next x coordinate, next y coordinate, and step size is given 0.1. so the initial point is 0, x0, y1, and gradient at 0, 1, because we are given curve is x plus y, so add these two, so we'll get 1, and the next x coordinate, because step size is 0.1, so that will be 0.1, and next y coordinate can be found by substituting in this equation. So previous y coordinate is 1 plus step size is 0.1 times the gradient we have calculated is 1, so that's equal to 1.1. Now the next new point with x and y coordinates is 0.1 and 1.1. Gradient will be sum of these two, is given in the differential equation, so 1.2, and then the next x coordinate is 0.2, y coordinate is given by the previous y coordinate, that is 1.1 plus step size times the gradient is 1.2, and we can use calculator to calculate, so that is 1.22 and 0. Similarly, the next x coordinate is 0.2, y coordinate is 1.22, and gradient is sum of these two, so 1.42, and the next x coordinate is 0.3, the next y coordinate is 1.1, 1.22 plus step size times the gradient, that is 1.42, and that's equal to 1.382, is equal to 362. So therefore approximate value of y at 0.3 is 1. Thank you.